Hello, welcome back to the storage room in Tehachapi, California. We're going to do more 2.7 examples. So another example, this is problem 4. See if my paper view is working. Seems to be. See how the light is. It's a little yellow. I had natural light, but it's dark outside now. Last videos I made up here. What's going on here? Okay, let's see. So we have this function that's our position function, and what they're wanting us to do is they're wanting us to find the velocity. So they're saying that s equals f at t, which is our position function right here, and t is greater than 0, and this is going to be measured in feet and seconds. So all I have to do in order to find the velocity, remember that the velocity equals the first derivative of s, and in this case, in order to find that derivative, which since they've said s is f at t, would be at f prime at t, right? Just making sure that all those ones. And so I'm going to have to use I can't divide that, so I'm going to have to use the quotient rule. So u is 9t, v is t squared plus 9, u prime equals 9, and v prime equals 2t. People have been asking me what the quotient rule is, so I'll write the quotient rule out here. I'll write it up here, quotient rule. Quotient rule. So it's u prime times v minus u times v prime divided by v squared. That's the quotient rule. And for me, how I know the quotient rule is I say crisscross applesauce. So I would be saying here, so v equals, and it's going to be 9 times t squared plus 9 minus 9t times 2t divided by t squared plus 9 quantity squared. Leaving the door open because the kitty girl, she was not happy about being locked out. But then I hope that you don't hear people, some other people are playing games here. And so you know how that can go if you're playing a game. So here, 9 times t squared, we're all happy here because the Padres won, and so that made us all happy. So this is 18t squared over t squared plus 9 quantity squared. And just cleaning it up a little bit, v equals 9 take away 18 is negative 9 t squared plus 81 So I can definitely factor out a 9 in the numerator, but I don't think it helps me. It's not going to reduce or anything like that, because if I factor out a positive 9, then I'll have negative t squared, and this is t squared down here. And so it just almost works. I mean, I have the opposite of what this is. I don't have... well, it's not even the opposite. If it was the opposite, I could make it the same by factoring out a negative. But the signs are just one up here, a negative and a positive, and here both positives. Not going to cancel. Okay, this is in feet per second. And then they asked me the velocity after 1 second. So all I have to do is put in 1. So the velocity here equals negative 9, 1 squared plus 81. And then here 1 squared plus 9 squared. And And I need a calculator. I don't know. That's what I'm saying. I'm saying I don't know. That moved my camera. Oh, I see. My camera is and that are attached with one another. Is that better on the light or worse? Worse, huh? I've not had it so shadowy, and but I think the natural light from outside last time really helped. So -9 plus 81 in the numerator, and in the denominator 10 squared, so divided by 100, so 18 over 25. Feet per second, which is the same as 0.72 feet per second. Either one of those. Haven't done this problem in a long time, so I don't remember if that's the answer. Usually I have a memory. Oh, yeah, that's the answer. But I don't. It's been so long. Okay, when is the particle at rest? And I don't have a very big spot for that. I feel kind of bad about that. But that's when we learned today when the velocity is equal to 0. So we have our velocity up here, and we're going to set that velocity equal to 0. So when the velocity equals 0, so that's when -9t squared plus 81 over this denominator equals 0. And we saw this before in a situation where you have a fraction, you have it equal to 0. And so what you're going to do is you're going to multiply by the denominator. And when you do multiply by the denominator, it wipes this denominator out. And when you multiply it by 0, you get 0 on the other side. So it just becomes when the numerator is equal to 0, right? So to clear the fraction, I would multiply by t squared plus 9 squared, right? And I would do that over here too. T squared plus 9 squared. I'm going to put parentheses around that. So these cancel, and this makes 0. So I get -9t squared plus 81 equals 0. And I'm going to solve that. And my choice on how to solve it, it's quadratic, t to the second. So I could use the quadratic formula. If I could factor this, then it would be okay to factor this. And so if I pulled out a -9, then I would have t squared minus 9. Negative times a negative is a positive, equals 0. So -9 times t plus 3 times t minus 3 equals 0. So I'm getting t equals -3 and t equals 3. And you could have used the square root method. You could also use the quadratic formula. I went ahead and factored it because it factored. But this one, actually all three of those methods would have worked on it. So you get to choose which one. And that's the one I ended up choosing. Now t can't be negative because it said that t was greater than 0. T stands for time here. So this is, the particle is at rest at 3 seconds. It seems like that was the answer to the last problem we did in the notes, which was problem 2. I think it was. So, okay. Then it wants to know, when is the particle moving in the positive direction? And so we're going to make a number line here. And we in here at 0, we're going to put 3 seconds because that's when the particle was at rest. On our number line, this is a number line for velocity. I want to grab the velocity over here. And where is it? Right here. And so this is my velocity equals -9t squared plus 81 over t squared plus 9 quantity squared. And what I'm going to do is I'm going to test points, is what my plan is. And I have the region over here between 0 and 3, and I plan on testing in that region, testing 1 or 2. Any value in that region would be good, and so I think I'll test 1. And so when I do, the velocity equals, and remember, I only care, is it positive or is it negative? So I'm going to be putting in, so I have my calculator right here. Oh, wait, I did 1 already. Silly me. And when I did, remember, we did that in part B, and I got positive. So that was good thinking to choose 1, since I already done it. And then I'm going to test something in the second region over here on the other side of 3. I'm going to test 4 seconds. I am going to put that in my calculator. So that is negative 9 times 4 squared plus 81 divided by, and I know that you could just say, figure out whether it's positive or negative without figuring out what the number is. It's negative, and can you see my calculator screen? But I was just so tired that I was just like, I'm just going to put it in. And so if I would have wanted to, I could have said, okay, let me reason this out. The denominator is always positive because it's squared. And so I won't worry about the denominator. And then in here, when I put that in, not negative 9 times 16 is bigger than 81, so it's got to be negative. And so certainly I could have done that. So they want to know, when is it moving in the positive direction, and from 0 to 3. Now at 0 itself, the velocity, if you put in 0, is positive. And so this time, when is the particle moving in the positive direction? Remember last time that we did a problem, 0 was 0. But at 0 itself, so if I test 0, right, I'm going to get the velocity is positive. So actually, it's moving in the positive direction from 0 to 3. It's not moving in the positive direction at 3, because at 3 it was 0. And so, but at 0, the velocity, if you put it in here, negative 9 times 0, so we get 81, which is positive, over a positive value. And so, yeah, so there we would have that. They want to know the total distance traveled during the first 6 seconds. And so we're gonna find that. And we're gonna have the distance it travels in the negative direction and the distance it travels in the positive direction, right? So the distance, I don't know if you can hear that, it's a train. In the negative, I'm going to say positive, because 0 to 3 is positive direction, is equal to s at 3 minus s at 0. So when I go back to my equation for s, I'm going to write it right up here. Can we see it? S equals, just remembering, 9t over t squared plus 9. So when I find s at 3, I'll be plugging in 3. So this is 9 parentheses 3, and then downstairs 3 squared plus 9. And so this is at 1.5, 3 over 2. Then when I put in 0, I actually get 0. So it went in the positive direction. It started at 0, and at 3, it was at 1.5. So it's went 1.5 feet. And then I want to know the distance it travels in the negative direction, distance it travels going backwards, right? And so it's going to be traveling backwards here in the negative direction. And it's going there from s at 6 minus s at 3. So I'm going to be able to come in here and edit and put in 6. And I get 6 over 5, which is 1.2. And it was started there at 1.5. So it went backwards. And so we get 1.2 take away 1.5. Negative 3/10 or negative 0.3. But remember, we wanted really the positive of this, right? So this was just that it was traveling backwards. So it just backed up this amount. And so, some people throw absolute value around that and to make it positive. And so certainly you could do that. And so I'm going to just say, so a distance, because distance is positive, of, that was a plus, 0.3. Thus, in total, is 1.5 plus 0.3, which is 1.8 feet. Does that seem sort of okay? Looks like an 18. I'll make my decimal point a little happier. And so 1.8 feet. Okay, so now they want us to draw one of those diagrams. I wish I had my textbook because I would get it out and show you the diagram that they have. We're just going to start off here at right here at time is 0. I know that S is 0. And if you wanted to list other things, you could. I think in the book that they only list time is 0 and I think they only list what time is and what S is, but I might be wrong. But I could name what the velocity is as well at 0, because I could go and find the velocity if I wanted. I almost found it up here, but I'm not going to worry about doing that. So it goes in the positive direction for 3 seconds. So it goes in the positive direction, this direction, until t equals 3. And at that point, s equals 1.5. And then what it's going to do is it's going to turn and it's going to go in the negative direction for the rest of the time. And they just kind of draw it. This one didn't go back and forth, but they just kind of draw it so that because it's just going back and forth on a straight line. So they just draw it so that you can see, and now it's just going in the negative direction until infinity. Okay. It asks us to find the acceleration. In order to find the acceleration, we need to have our velocity back on here. So I'm going to write our velocity right here. Velocity equals negative 9t squared plus 81 divided by t squared plus 9 squared. And I better make sure that I have that right. I think I do. And so I'm going to find the derivative of that. Remember that the acceleration is equal to the first derivative of the velocity. In order to find the first derivative of the velocity, I'm going to have to use the quotient rule because I can't divide that. U equals negative 9t squared plus 81. U prime equals negative 18t. And V prime equals t squared plus 9 quantity squared. And V prime, and I have the choice of using the multiplying that together, foiling that together, writing it twice and foiling it together to find the derivative, or using the chain rule. And the only reason that I'm thinking about using the chain rule is that I think it's going to be easier to reduce, because then V and V prime are going to have the same value in them, and then I'll be able to cancel that value out or reduce that value out. And so that's the reason I'm going to use the chain rule. So how the chain rule works is you think about the outside. So this would be in your thoughts. Am I writing where you can see? And that is something squared. And you think about the inside, which is t squared plus 9. And then what you do is you take the derivative of the outside, which is 2, and then t squared plus 9, right? To the 1. I usually write it like this, right? The 2 comes down in front, leaves the exponent of 1, and what would I have on the inside there? We'll evaluate it at the same inside, t squared plus 9, and then times 2t. And I don't allow myself to write that 1 because it looks like a prime, and so I wrote it there so that you could see that I just used my power rule, but now I'm kind of erasing it. And this is 4t. And so when I put it together using my quotient rule, I think I'm going to allow myself to say, hey, that's 4t. And so now when I go to use my quotient rule, my acceleration equals, and it's going to equal negative 18t. So I'm just doing this quotient rule that I wrote right here, right? U prime v minus u v prime divided by v squared, and I have the muscle memory of the pattern. A pattern memory is what I have going. I say I'm going to start here, and I'm going to multiply these two things together. So this is t squared plus 9 quantity squared minus, and then I'm going to multiply these two things together. And so I'm going to write this as negative 9t squared plus 81, and then times 4t, and I'm going to t squared plus 9. My house is filled, they're not too loud, but they're way across the other side of the house. Okay, so here's my dilemma. The cat gets all upset and can't win for losing here. And then I'm going to square that. So if I square something that's squared, I get raised to the 4th is what I get. So this would be t squared plus 9 raised to the 4th. So if you square something that's squared, you get raised to the 4th is what you get. So if I had something that was squared, I was going to make it a star, right? And it was squared. And if I squared that, then that's the power rule. And it's 2 times 2 is to the 4th. Okay, so now I want you to notice that t squared plus 9 squared and t squared plus 9 to the 4th and t squared plus 9, because the way the quotient rule is, you always have v here, you always have v here and v squared here, and they don't typically cancel out. And the reason they don't typically cancel out, because this term over here doesn't have v on it, and so it doesn't cancel out. But in this case, because v and v prime have the same term, t squared plus 9, you are going to get some reducing. Now you can factor it out if you like, or you can just say that I have this term here, 3 terms. 1, this is a big term there, 2 terms, and here is the 3rd term. And those 3 terms have, this one has 2 of those t squared plus 9s. This has 1, and this has 4, so I can only cancel out 1. And that might be easier to do, just to go and cancel out 1 than to factor a t squared plus 9 to the front and then cancel it out. And in the bottom, write this as t squared plus 9 to the first times t squared plus 9 to the third. And so So you do you. I have to factor it out because this video is being monitored by the Math Society. Okay, so what I'm going to have here is I'm going to have negative 18t, and I'm going to have a t squared plus 9, and minus, and then the negative 9t squared plus 81, and then the 4t, and then I factored out the 9t squared in the front, and then in the denominator I'm going to factor out one of them, so there's one of them, and I'm going to leave 3 of them right beside it so that there's 4 of them still all together, and then this cancels with this because that's the entire going with the entire numerator. And then when the dust clears, they want me to plug in 1 second too, so I got to clean this up in not very much room and plug in 1 second. You can see that the algebra is just a little harder than I am filling, right? So 18 times 9 is negative 162. And I feel like that I could lose a negative there if I'm not careful. So I'm thinking about even erasing it and writing the 4t first. I wish I would have already done that when I was laying it down before. So 4t, because it's a monomial, it'll make it better for me. And then the binomial, negative 9t squared plus 81. Okay, and I had already factored that guy out. So that's going to make a negative times a negative is a positive 36 t squared, t cubed, 1, 2, 3 of them, minus 81 times 4, 4 times 81. Oh, that's 4 times 8, friend. 324 t, all divided by 3 of those, friends. So like terms, I have 36 take away 18 and 162. So when I do 36 take away 18, I get 18. So this is A equals 18t to the third, and then negative 162 and negative 324t make 486t, all divided by t squared plus 9 cubed. There's A. The units on this are, I hope that you're shouting at your screen, feet per second squared. And then they asked me to do this to find out at t being 1, which is a nicer number than could have been. And it's possible for acceleration to be positive or negative, just like velocity can be positive or negative. So if it comes out negative, I'll be okay. And if it comes out positive, it just is what it is. I'm putting it in my calculator because all of a sudden I can't take 18, take away 486. And in the denominator, I'm going to have 10, 1 squared cubed, which is 1,000. So I'm getting negative 17 over 250. Feet per second squared, which is equal negative 0.468 feet per second squared. So either one of those would be okay. Okay. And then they asked me to graph the position, the velocity, and the acceleration functions. And I wouldn't require that you graph those. And I realize now, without them being on the screen, that I don't know which one is which here. And so, but I could probably figure out, I know S goes through the origin, and A must go through the origin. And then I knew that S at 3 was 1.5. So here's 3. So my choices for S were this one or this one. And at 1.5, this one is at 1.5, right? Because that's 1, so another half more. So this function right here is S. And then I want to figure out which one. Oh, was this the one I had one of them typed in wrong? At 0, is this at 1? It is, because it's 81 over 81. Okay, so this one must be the velocity. There was one that I had typed in wrong and that I had given the graph up, but what was it on? I don't know. I don't think it's this one. So this must be the acceleration. Okay. Next story. When is the particle speeding up? When is the particle slowing down? And so what we need to find out is when we already know when the velocity is equal to 0 when it's at rest. We need to know when the acceleration is equal to 0. So here's my acceleration. So we want to set that to equal 0. And the first thing we would do is multiply by the denominator, and that would cancel the denominator, and we'll multiply it times 0. So it's really just when is the numerator equal to 0. So that's kind of nice. I mean, super nice. And I'm not sure if I'll be able to factor this all the way, or if I'll have to use something else other than factoring. But I can factor out a t, and maybe I can factor out an 18 too. Let me see. 486 divided by 18, I don't know. It's actually 27, so I actually can. So 18t, and then this would be t squared minus 27 equals 0. So this would mean that 18t equals 0, which means t equals 0. And also t squared minus 27, which is not a difference of squares, equals 0. So that would mean that t squared equals 27. I'm going to use the square root method of solving it. So t equals plus or minus the square root of 27. And 27, I think, is 3 square roots of 9. So the square root of 27, 3 square roots of 3. I don't know why I said 3 square roots of 9, but 3 square roots of 3. And time needs to be positive. So this is 3 square roots of 3, and time is positive, right? Okay, then what I want to do is I want to put these on my number line, and I'm going to test the regions out. So I already know that my velocity is, let's see, 3 square roots of 3. Where's that at? It's over here. Okay. So we already knew, because we had already found it, that the velocity was positive from 0 to 3, and actually it was positive at 0 itself, and then it was negative after. So I'm going to write negative on either side of that value, and this was for the velocity. And then what I want to find out, and I like to draw my little lines up here like this, and so what I want to find out is, what about the acceleration? Well, the acceleration, it was 0 at 0 and at 3 square roots of 3. So, and I don't care what happens over here, so I'm not even going to test. but basically I have this divider. So I need to check something in this range and find out if it's positive or negative, and then check something in this range over here and find out if it's positive or negative for the velocity, the acceleration. So I'm going to test, I'm going to write this down here. I'm going to test in the acceleration, t equals, and all I care about if it's positive or negative. And I can even test 3 itself, because I need to test something between 0 and 3 square roots of 3, which 3 square roots of 3 was around 5. And so I can't test 0 because 0 itself was a place where the acceleration was 0. So I have to check something in the region. And so so I can test 1 because I already know what 1 is, and that would be great. 1 for the acceleration is negative. So right here for the acceleration is negative, and in this region as well is negative. And because everything from 0 to the square root of 3 square roots of 3 should be the same for the acceleration. And then I'm just going to make sure that if I test something after 3 square roots of 3 in the acceleration that I get positive. I think I probably will. So I'll test 6 because 3 square roots of 3 is 5. So I'm putting this into the acceleration. So the acceleration 18, it's a fraction. So 18 t to the third. I don't know why I put parentheses there. Times 6 to the third minus 486 times 6. Now the denominator down there is positive because when I put in 6, and so that's not really going to change the sign. But I'm going to go ahead and just put it in because I've had enough today. And so I'll just put it in just like I see it. And did I do 6 raised to the 6th instead of 6 raised to the 3rd? I did, and that sure could change things. But I do get a positive value. That's all I cared about, that A was positive. I suspected it was going to be positive because it typically alternates, although it doesn't always alternate. I was telling you about that. There's the rule, and it has to do with the multiplicity. And so here it was, we were solving 18t to the third, right? So that would tell us 3 solutions. Here's one solution, and then the plus or minus is 2 more solutions. So there's 3 solutions, and none of them are repeated. So none of them have a multiplicity of anything other than 1. So it should alternate at all of the roots. Now the other root we had was negative 3 square roots of 3, which we don't care about at all. Okay, so because it's not in where our time is. So we wanted to know when it was speeding up, and that is where this particle was speeding up. That's where the velocity and the acceleration have the same sign. In this case, they're both negative between 3 and 3 square roots of 3. And slowing down between 0 and 3 and 3 square roots of 3 and infinity. And so that's our story there. There's different ways of going at it. This is the reason that they ask you for this graph over here, so that you can look at where the velocity is positive and the acceleration's negative. So where the velocity is positive and the acceleration is negative, it should be slowing down. And it's positive because it's above the x-axis, and it's negative because it's below the x-axis. So that's the reason they asked you for the graph in H. And I could have used the graph here in H maybe to answer the questions, to get my sign chart going, my positive and my negative going over there on my velocity and my acceleration. And so that's certainly a way of doing it as well. I chose not to do it that way because here it wasn't clear where it crossed, where A crossed, and it's barely above the axis. It's barely positive over here. Now I do know where it crosses. It crosses at 3 square roots of 3, which is around 5.1. So somewhere in here is where it's crossing. I couldn't see that on there, and so I did it the way I did it here. Then it asked me what is the displacement of the particle on the interval 0 to 6. And the good news is the displacement is equal to S at 6 minus S at 0. And we had S written right over here. And so here's S. I don't believe we have found S at 6 yet. Oh, wait, maybe we did. There it is. It was 1.2, so there's no reason for me to put it in the calculator again. So S at 6 is 1.2. And S at 0 was 0. I'm just remembering, but I could go back over here and I could look it up where I already found it, right? S at 0 was 0. And so the displacement is 1.2 feet. So we did a lovely job on that. So from where it started, it wasn't on the screen. From where it started, it is from the beginning of the time interval to the end of the time interval, it's 1.2 feet in the positive direction. Okay, now, if you wanted to read all of this story that I got off the internet about, I think some of it I got off the internet and some of it I wrote myself. I think some examples to visualize this, I think came from me. I think I wrote that part, and I think this part came from the internet. If you want to read about acceleration, speeding up and slowing down, then you definitely can, and that would be great. One more 2.7 example. Okay, it says, this is problem 24. Some of the highest tides in the world occur in the Bay of Fundy in the Atlantic coast of Canada. At Hopewell Cape, the water depth at low tide is 2 meters and at high tide it is 12 meters. The natural period of oscillation is a little more than 12 hours on June 30th, 2009, high tide occurred at 6:45 a.m. This helps explain the following model. This helps explain the following model for the water depth in meters as a function in time in hours after midnight on that day. So T is the number of hours after midnight on that day. How fast was the tide rising or falling at the following times? So if we want to know the rate at which the tide is rising or falling, then if we want to know how fast something is happening, then we're going to have to find the derivative. And so I need to find the derivative of that thing right there. So, and then I'm going to plug in for my time. After I do, I'm going to plug in 3 because it's the time since midnight. So 3 a.m. is T is 3. So at least it's kind of nice that way. So first I have to find the derivative. So the derivative of 7 is 0. The derivative of 5 cosine, and then I have this mess here. And it's my choice whether or not I want to multiply that mess together there, or if I want to leave it as a multiplication like that, because this is a constant here. And I just feel like it's going to mess me up if I just feel like no matter what I do, I'm going to mess it up. That's being negative. I'm sorry, but I'm kind of tired. Okay, so here, because my cosine is this complicated thing right here, not just cosine of x, not just cosine of t, I'm going to have to use the chain rule. And so d prime at t, so I'm taking the derivative of that. Taking the derivative of 7, it's 0. Oh, I was going to write room so that I could say my outside function was. And so here's going to be my outside function. And I am going to write 0 for the derivative of 7 so I don't mess it up. So 5 times the cosine of that complicated mess is the outside. And then the inside is 0.503 times t minus 6.75. Okay, so d prime at t equals 0, and then the derivative of the of 5 cosine of some inside, the derivative of cosine is negative sine, so this would be negative 5 sine of, and then that would be the same inside, which I'm going to have to make it bigger for that inside to fit in there. Times, and then I want to take the derivative of this. Now, I just want you to imagine if you multiplied it together. I said I thought that I would mess it up if I multiplied it together because I was tired, and I thought I would mess it up if I didn't. And so what we're going to do is we're going to imagine if I multiplied it together. If I multiplied it together, it would be 0.503 times t, 0.503 times 6 something, which would be 3 something. And so the derivative of 0.503t is 0.503. And then the derivative of the other thing, which was 3 something, I don't know what it was, it doesn't matter, 0.5 times 6.75, 0.503 times 6.75 is a constant, right? And so the derivative of it is 0. So now what we have to do is we have to just put 3am in here. So we wanted d prime at 3 equals, so we're going to put that 3 right in there into our little calculator. And so since I'm just asked to find the number, I'm going to put 3 in and I'm not going to worry. So my calculator is in radians. Seems like I get to do in Calc 3 with Kayla, and then my calculator gets in degrees all the time. So I have to make sure of that. I have said it in our class that your calculator will always be, for Calc 1, in degrees. Oh, I wanted 3 in there, not 1. I have my finger making a 1, and I was trying to plug in t as 3, minus 6.75, and that's the whole input into the sign. So I do think I need the double parenthesis, and then I need times, I'll put it in parentheses, 0.503 out here. So I get positive 2.39. They're probably going to put 2.4 in the back of the book. And let me see, what are the units here? The depth's in meters, and the time is in hours, right? T stands for 3 hours past midnight. So this is meters per hour. And anyway, so I think that was good. It was lovely. And so the tide is at 3 a.m. The tide is changing at 2.4 meters per hour, and it's rising. And so the tide is coming up in 1 hour, but at that moment, that's the time of it, the rate that it's that it's rising up 2.4 meters per hour, right at that. Okay, that was fun. Okay, something wonderful is going to happen. There's related rates. That's tomorrow. That's another day. Okay, that's the video.